Hello, this is Mr. Collier, and today we're looking at parallel and perpendicular lines. So if we have two lines that are parallel, then their gradients are going to be equal. Alright, and if two lines are perpendicular, then the gradients are negative reciprocals. Okay, so what that means is if the slope of one line happens to be half, and the slope of the perpendicular line is going to be negative 2 out of 1, which equals negative 2. Another way to say that is if two lines are parallel, then if you multiply the slopes, or the gradients, if you multiply them, you will get negative 1. For example, over here, our two slopes were half and negative 2. So if you take half and you multiply it by negative 2, you do get negative 1. So that confirms or proves that those two lines are perpendicular. So let's take a look at some examples. Firstly, determine which pair of lines are parallel. So it's very easy to see in the first one that the slopes are equal, so they are parallel. So we can say their slopes are equal. Okay, therefore they are parallel. And the second one, we can see the slope of the first line, and we'll call it M1, is negative 2. And for the second one, we can't really see the slope right yet. We have to change this equation into slope-intercept form. So we're going to solve for y. So we're going to subtract x from both sides. We have 2y equals negative x plus 3. Okay, and you can think of that as a negative 1 plus 3. And now to solve, we're going to divide both sides by 2. So we get y equals negative half x. And then we do 3 divided by 2 equals 3 out of 2. That part's not even really important actually because we're just looking at the slopes. So the slope of this second line, say m2 equals negative half. So the slope of the second line is negative half, and the slope of the first line is negative 2. They're not equal, so therefore they are not parallel. Okay, let's take a look at the next example. Now we're looking at some perpendicular lines. Are these two lines perpendicular? Well, here's the slopes, and you can visually inspect to see if they're negative reciprocals. Or you can use the rule m1 times m2 equals negative 1 for perpendicular lines. So we're going to check that for these two. And we have half times negative 2. Does that equal negative 1? Yes, it does. So therefore they are perpendicular. Okay, in the next example, we can see the slope for the second line. So m2 equals 5 out of 8. And we can't see it for the first one, so we have to solve for y. We'll have 5y equals negative 8x plus 9. Then to solve for y, we divide by 5. We get y equals negative 8 fifths plus 9 fifths. So here's the slope. Slope is right here, and that should be an x there, but there's your slope. So slope 1, we'll call it, is negative 8 fifths, and you can visually inspect it. It is the negative reciprocal of m2, or you can write 5 eighths times that's right, negative 8 fifths, and you multiply that out, you do get, because this cancels and this cancels, and you have a negative sign, so you do get negative 1. So therefore they are I'll use a perpendicular symbol. They are perpendicular. Now in this equation it says that there's two lines, there's two lines that are parallel. One is the line through AB. Okay, and we're looking for another mystery line with a gradient of 4, and it's parallel to this line. So actually what we have here is the slope of this line as well. Okay, so this second line has a slope of 4, then also the first line is going to have a slope of 4. So if I have these 2 points and I join them and I get a slope of 4, I can use the slope formula to figure out the value of a. So slope equals y2 minus y1, y1 out of x2 minus x1. Then I could just substitute in all the values that I know. I know the gradient is 4, so I can write that in there. I can subtract the y values. I can do a minus 3 and 3 minus 1 on the denominator. Start solving. So I have a minus 3 out of 2. I can multiply both sides by 2 to get rid of that 2 down there. And I will get 8 equals a minus 3. So a equals 8 plus 3, and a equals 11 is our value for a. Let's take a look at another example. It says write down an equation of a line that is perpendicular to y equals x and passes through this point. So first of all, let's take a look at this line y equals x. We can write it as y equals 1x, and we can see that the slope equals 1. And if we want to find the negative reciprocal, so that's the slope of line 1. Now we have another line called line 2. We don't know the equation, but we know the slope has to be the negative reciprocal. So if the slope for the first line is 1, which we can write as 1 out of 1, then the negative reciprocal is going to be negative, and we flip the denominator and numerator. This is going to be the same thing. It's just going to be negative 1. Okay, and you can verify that by doing 1 times negative 1. Do you get negative 1? Yes. So 1 and negative 1, if you have a slope of a line is 1 and another one is negative 1, they are going to be perpendicular. So we know for our mystery line, we'll call this line 2, and this one's line 1. So for our mystery line, line 2, we know that y equals mx plus b is the slope-intercept form. But we know the slope is going to be negative 1, and we don't know the y-intercept. So what do we do here? We use our other piece of information, which is 3 comma 6, and we substitute it into the equation to find the y-intercept. So 6 equals negative 1 times 3 plus b. 6 equals negative 3 plus b. So b is going to be 6 plus 3, and b equals 9. So the answer, the equation, is y equals negative 1x, or just negative x, plus 9. That's the equation of the perpendicular line through the point 3, 6.